Good afternoon, distinguished experts. I'm Tian Huihui, the author of the paper Research on Traffic Flow Prediction based on ISMA-CNN-GRU model. Let me start my report. This report is mainly divided into three parts: introduction, methodology, and experimental results. The first part is the introduction. With the progress of mankind and society, traffic congestion is becoming more and more serious, and it brings great damage to everyone's life and health. There is a need to study an efficient and practical prediction method to further realize intelligent traffic. Neural networks are widely used in traffic flow prediction because of their high operational efficiency and independent learning ability. Therefore, this paper starts from the neural network to improve the traffic prediction accuracy and use intelligent optimization algorithm to find the optimal combination of hyperparameters for the network as the goals of research. The method section begins below. For the feature of spatial temporal coordination of traffic flow data, Tian and GRU are combined to form a model to improve the accuracy of traffic prediction. Tian uses both local connectivity and shared ways to identify spatially relevant features, which can effectively reduce the complexity and errors such as overfitting during data processing. Therefore, this paper used CNN for spatial feature mining of traffic flow. GRU has a simple structure and performs better in time series forecasting, so it can be used for short-term traffic forecasting. The CNN-GRU framework diagram is shown in the figure. It includes convolutional layer, pooling layer, GRU layer, and fully connected layer. Aiming at the problem that GRU network parameters are difficult to determine, an intelligent optimization algorithm is used to find the optimal combination of hyperparameters for GRU. As one of the intelligent optimization algorithms, blind mode algorithm SMA has the advantages of few parameters, simple implementation, and strong optimization ability. So we select SMA to optimize the hyperparameters of neural networks. But SMA also has the problems of low initialized population quality, slow converging speed, and easy to fall into local optimal. To address these problems, this paper proposed the improved blind mode algorithm, ISMA, which uses the 10 chaotic mapping to initialize the slime population and increase the population diversity. From the distribution plot of the chaotic sequence, the 10th chaotic sequence is relatively more uniform. From the distribution histogram, its value probably in each distribution segment is relatively uniform. And we also add an adaptive inertial weighting strategy in the iterative phase to improve the exploration ability of the algorithm in the global space so that the slime population can be searched more effectively. So the ISMA-CNN-GRU model is built to predict the short-term traffic flow. First, the traffic flow is pre-processed and transformed into a two-dimensional spatial and temporal matrix, and the training set is fed into the convolutional neural network to extract the spatial distribution features of traffic flow. After convolutional operation, the data are transferred to the pooling layer, which reduces the dimensionality of the model to improve the computational speed of the model while reducing the parameters. The final data are combined by the convolutional neural network to obtain data samples with the spatial characteristic. The local features extracted by the convolutional neural network are then used as input to the ISMA-optimized GRU to further extract the temporal features of traffic flow. Finally, the predicted results are output through the pooling connected layer, which is also the output layer. The third part is the experimental results. The selected dataset contains traffic data collected every 15 minutes from August 1 to September 13 at 7 stations on the M25 freeway near Heathrow Airport, UK. In order to observe the advantages and disadvantages of the prediction effect of ISMA-CNN-GRU model, this experiment takes the traffic flow data from P station as an example to make predictions, with a sample size of 960 for the traffic flow from August 25 to 30 and September 25 to 30, and compare the prediction results of APSO-GRU, CNN-GRU, SMA-CNN-GRU, and ISMA-CNN-GRU models, and plot the fitting plot between the predicted values of each model and the true value of traffic flow. The ISMA-CNN-GRU model can fit the true value curve better. It can be seen that although the prediction results don't show a significant difference between summer and autumn, the ISMA-CNN-GRU still show high prediction accuracy. The results based on the error estimation evaluation matrix are shown in table. The prediction accuracy of SMA-CNN-GRU model is 98.4787%. In addition, the highest coefficient of determination of ISMA-CNN-GRU on the dataset is 0.9661, which is closer to 1 compared with other models, which reflects that this model can learn the changing pattern of traffic flow well and has high prediction accuracy and verifies its feasibility in traffic flow prediction. In addition to the error estimation evaluation index, the experiment also evaluated based on the interval prediction evaluation index. When the confidence level is 95%, PICP is 1, indicates that the true value falls within the built interval. The minimum CWC value of the ISMA-CNN-GRU model was 0.628. It fully illustrates the superiority of ISMA-CNN-GRU model because when the PICP is determined, the smaller the PINAW and the smaller the value of CWC, the narrower the prediction interval, indicating better prediction. In a word, the experimental results show that the ISMA-CNN-GRU model has better prediction performance. Finally, thank you for listening.